Your production FastMCP server is handling sensitive OAuth tokens, but they're sitting in plain text, exposed to anyone with access to your storage backend. We'll secure this by wrapping Redis storage in an encryption layer, then configure GitHub authentication with explicit JWT signing and encrypted token persistence. Here, how to lock down your auth flow for real-world deployments.
Import auth. From FastMCP, server, auth providers, GitHub import GitHub provider. From key value, AO stores, Redis import RedisStore. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Auth equals GitHub provider. Client ID equals OS. Environ GitHub client ID. Client secret equals OS. Environ GitHub client secret. Base URL equals https://yourserver.com. Hash explicit JWT signing key, required for production. JWT signing key equals OS. Environ JWT signing key. Hash encrypted persistent storage, required for production. Client storage equals Fernet encryption wrapper. Key value equals RedisStore. Host equals Redis. Example, com, port equals 6379. Fernet equals Fernet. OS, environ storage encryption key.
This demonstrates the storage abstraction pattern with defensive security layers, a common approach in production-grade systems. The code shows how to configure persistent, encrypted storage for authentication state while completely isolating the application from storage implementation details. What makes this distinctive is the combination of pluggable backends with mandatory encryption wrappers, enforcing security without sacrificing flexibility. The pattern works through compositional layers that separate concerns. The authentication provider handles OAuth flows, the storage backend manages persistence, and the encryption wrapper enforces data protection. Each component exposes a standard interface, allowing you to swap Redis for disk storage or change encryption schemes without modifying the core authentication logic. This declarative approach means you configure behavior at startup rather than scattering storage logic throughout your codebase. This approach solves two critical production problems: secure persistence and deployment flexibility. Without it, you'd either lose state on restarts in memory or risk exposing plaintext tokens unencrypted disk. The trade-off is minimal: just wrap your storage backend, while gaining the ability to scale from local development to distributed cloud deployments with identical application code. Use this whenever you need persistent, secure state that must work across different infrastructure setups. Let's break it down line by line.
Import auth.
Imports Python's auth module for environment variable access. This enables secure configuration by pulling sensitive values like API keys from environment variables rather than hard-coding them.
From FastMCP, server, auth providers, GitHub import GitHub provider.
Imports GitHub provider from FastMCP's auth system. This handles GitHub OAuth authentication, managing the OAuth flow, token exchange, and user validation for your application.
From key value, AO stores, Redis import RedisStore.
Imports RedisStore, a persistent key value storage backend. Handles session data and encrypted client storage for production environments, replacing volatile in-memory solutions.
From key value, AO, wrappers, encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer for key value stores. It automatically encrypts all data before storage and decrypts on retrieval, ensuring sensitive OAuth client data remains secure at rest while maintaining the same storage interface. The wrapper pattern here eliminates the need to modify existing storage code.
From cryptography, Fernet import Fernet.
Imports Fernet from cryptography, a symmetric encryption implementation for secure data encryption. This handles the actual encryption-decryption of sensitive client storage data, ensuring it remains protected at rest.
Auth equals GitHub provider.
Instantiates the GitHub OAuth provider for FastMCP authentication. This centralizes all GitHub login flows, token handling, and user validation in one reusable component. The provider pattern here isolates auth logic from your business code.
Client ID equals OS. Environ GitHub client ID.
This pulls the GitHub OAuth client ID from environment variables, not hard-coded values. Critical for security, prevents accidental credential exposure in version control while enabling different configurations across dev, staging, and production environments.
Client secret equals OS. Environ GitHub client secret.
This loads the GitHub OAuth client secret from environment variables, not hard-coded values. Critical for production security, prevents accidental secret exposure in version control while enabling secure credential rotation.
Base URL equals https://yourserver.com.
Sets the OAuth redirect base URL for GitHub authentication. This must match your server's public address, ensuring GitHub redirects back to the correct endpoint after authorization. Required for production deployments to prevent redirect URI mismatches.
Hash explicit JWT signing key, required for production. JWT signing key equals OS. Environ JWT signing key.
This sets an explicit JWT signing key for production-grade security. Without this, FastMCP defaults to an insecure ephemeral key, defeating authentication integrity. Required for all production deployments to prevent token forgery.
Hash encrypted persistent storage, required for production. Client storage equals Fernet encryption wrapper.
This implements encrypted persistent storage using the wrapper pattern. The Fernet encryption wrapper handles automatic encryption-decryption of all stored data, preventing exposure of sensitive OAuth tokens in Redis. Required for production to meet security compliance.
Key value equals RedisStore. Host equals Redis. Example, com, port equals 6379.
This instantiates a RedisStore as the persistent key value backend. Redis handles high-speed storage and retrieval of session data, critical for production-scale authentication where in-memory storage would fail. The host and port parameters specify the Redis server location, enabling distributed session management across multiple application instances.
Fernet equals Fernet. OS. Environ storage encryption key.
This initializes a Fernet encryption instance using a key from environment variables. Fernet provides symmetric encryption for the Redis storage layer, ensuring sensitive client data remains encrypted at rest. The key comes from storage encryption key, which must be securely managed in production. This closing parenthesis terminates the GitHub provider instantiation, finalizing the authentication configuration with all required production settings, encrypted storage, JWT signing, and OAuth credentials. Without this, the object would remain incomplete, causing runtime errors during server initialization. This closing parenthesis finalizes the GitHub provider instantiation, completing the authentication configuration. It ties together all security components, OAuth credentials, JWT signing, and encrypted storage, making the provider ready for production use. Production-grade authentication pattern. The GitHub provider configuration demonstrates FastMCP's production requirements for persistent, encrypted token storage and JWT signing, ensuring seamless server restarts without losing authentication state. Omitting the Fernet encryption wrapper leaves OAuth tokens exposed in plain text, violating security best practices. Always store sensitive keys in environment variables and use Redis for distributed deployments.
The key that never touches the code secures everything the code touches.